Hey, Waf.
Hey, Caitlin, what are we chatting about today?
Today, we're going to talk about observational studies, confounders, and stratification.
Tell me more.
So we've been talking a lot about experimental design, and we said that the ideal experiment is the randomized controlled double-blind experiment. But sometimes we can't always do that. Wade, do you have any examples where it would actually be impossible to do a randomized controlled double-blind experiment?
So almost everything I do, I feel like I can't do controlled experiments because I build a lot of things that I put on the web, and I just have people arriving there, and I can't control whether or not they view my site or not. I'm just lucky to have the data of what they did once they got there. And I can't decide if they should view visualization A or B. I can just see how they viewed visualization.
Exactly. So you as the researcher have no control over who's in the treatment and control group. And that's called an observational study. And with observational studies, they are not ideal because it's difficult, while they may show correlation, it's difficult to show causation because the treatment and control groups are going to be different. So usually what we see with an observational study is that the treatment may be associated with some response, but we can't say for sure whether it causes the response. But with any study, there's always going to be two options. There's always going to be option number one, which is that the treatment causes the response. And if that's the case, then we're going to have something that explains how or why that happens. So I like to think of these as something called a causal link, and I like to use diagrams to show them. So if we have a causal link, if the treatment does cause the response, because even though it's an observational study, that could happen, then we have our treatment, and we have our response, and then there's this causal link connecting them. So I'm actually going to draw a box in the middle, and I'm going to say this is the causal link, causal as in cause, and the treatment is directly related to the causal link, which is causing the response. And this, again, the causal link, this thing right here, answers the question, how or why? What exactly about the treatment is causing the response? So this could happen, option number one, but what more likely happens in these observational studies is option number two, that our treatment does not cause the response, that our treatment is just associated with the response. So I'm going to say the treatment does not cause the response. And what happens is that there are these things called confounders. And confounders are just differences between the treatment and control group that make it look like the treatment is causing the response when really the confounder itself is causing the response. So if I were to draw a similar diagram, we have the treatment and we have the response. And the confounder is something that kind of mixes up our results. So this right here in the middle is the confounder, and this is what's actually causing the response, and it's also related to the treatment. So a confounder is a third factor that's a difference between the treatment and control group that makes it look like the treatment is causing the response. So I'm going to say this is a difference between the treatment and control group. So if a study is observational, we have to be aware of confounders. And I think it'll be good to think about an example.
I'd love an example here.
Yes. So Wade, back in the day, there were studies that showed that carrying lighters, so for my example, I'm going to use this example. Carrying lighters led people to get lung cancer.
Okay, so lighters are causing lung cancer.
Yeah, so that's what people thought. They were like, oh my gosh, there's something about the lighters that's causing lung cancer. They thought there's a causal link. There's something that happens when you use a lighter that leads you to have lung cancer. But this was an observational study. There was no one assigning people to actually carry lighters and assigning people to not. Instead, they were just observing what people naturally did. So the first thing that happened was that people said, okay, lighters caused lung cancer. So they said there has to be a causal link that is relating these two things, because why are we seeing this connection? And some people thought maybe it was lighter fluid. They said maybe the lighter fluid, like when people use the lighters, they were exposed to this lighter fluid and that caused lung cancer. So they said, okay, there's a causal link. But upon further investigation, this actually wasn't the case. They were able to test it out and see, okay, was the lighter fluid actually causing lung cancer? And that wasn't what was happening. Instead, there was a confounder. So really what happened was that the lighters were associated with lung cancer, but there was something else that was mixing up our results. So there was this third factor that was actually causing the lung cancer and was related to carrying lighters.
Oh, was that just smoking?
Yeah, exactly. So with smoking, we know now that smoking causes lung cancer. And if you're smoking, you're more likely to carry a lighter because you need one to smoke. So this confounder, this third factor, was actually the true cause of the lung cancer and not the lighters. So lighters are associated with lung cancer, but really the confounder smoking was what was the true cause. And because it's also related to the treatment, it was making it look like the treatment caused the response. So this is something definitely to be aware of with observational studies. We always want to think, what are possible confounders? And again, there are differences between the treatment and control group. In this case, our treatment group was lighters, our control group was no lighters, and people who carry lighters were more likely to smoke.
Interesting. And that was Confounders and Observational Studies.